Hi everybody, welcome back. Back to work on the TIG torch, the Airco. I got my eBay item in, and a couple other eBay items, but this is the, for those of you who've been following along, this is the deal I got on eBay. What I really wanted was this item, which is a thermocut description: power cable, 25-foot vinyl, quantity 1, lot number blah blah blah, part number is a 45V04, made in the USA, which is nice. There's a price sticker on this. It looks like it has a date of 5/15, May of 2015, maybe. $50.76. So this was listed as brand new, never used, like a new old stock situation. Alright, so I'll open this in a second, but the reason why I paid a couple bucks more for this one is because included with this wasn't the cheapest one. The cheapest one was a couple dollars less, but this one was a couple bucks more and included this, and also this 41V32 hose. This is a 25-foot water hose. This doesn't have a price sticker on it. And then also was this bag, and the description title was kind of ambiguous. It didn't really, it just said Temple 350 F. Well, what these are temple sticks for testing the temperature of something you're going to weld when you preheat it. I have some temple sticks. So that's what a temple stick looks like these days. So if you search online, you tend to find that all the temple sticks look like this. This one happens to be a 300-degree one, so you can get them in different ratings. And the way these typically work, basically as you use the stick and you touch the surface, if the temperature, if the surface temperature of what you're preheating reaches 300 degrees, when you touch the stick to it, the stick will melt, and that's the indication that it's ready to go. Alright, so I take this off. So there's what's inside there. Okay. Alright, so you have that stick out a little bit. This nose piece has got slits in it. It's almost like a collet. So that when you put this metal part is almost like a collet closer. You tighten it down, okay, it will squeeze down on that. And so now that when I push, see, it doesn't want to go in. So now that's ready for use. When you're done using it, you can retract it, okay. So this is the typical way that they have these now. So these run like 12 or 15 bucks a pop. I couldn't see how many were in the bag, but I figured, well, that must be a really good deal. Well, they came in, and I'm not upset about it, but these must be some sort of obsolete, discontinued temple stick design, because I have searched high and low and cannot find these anywhere. These are definitely temple sticks. They actually have the manufacturer name. Well, oddly enough, that one doesn't, but all the other ones, they're clearly marked Temple 350 right on them. 350F for 350 degree. What makes these unusual is that these have this weird ratcheting design. Okay? So the idea is that you've got this little knob, okay, and it's got the little shirt pocket clip there. But you get a little knob right here, okay, and as you turn the knob, it actually causes that to stick out. And I can see why this design's not so great, because it seems to not stay out as well. Okay. So I think these are still going to be usable. I think just not the greatest design. Now that one, okay, at first I thought maybe that one was a used up one, but it turns out that one broke. So once this gets used up a little bit, then I'm going to have to, here we go. There's the rest of it's in there. All right, so this is what I ended up getting as the bonus, was these weird temple sticks. 11 of them. This will last me more than a lifetime. The amount of stuff that I need to actually monitor when I preheat. Anywho, that was a nice little bonus, a little extra. Believe me, if they were these, the modern typical ones, I would probably keep a few of them and sell the rest of them, turn right around and resell the rest of them at like $5 a pop, which would be a good deal for somebody, and then pretty much pay for this whole lot. Let's look at this water hose just to see if it really is new and unused. Only because, like I said, this looks like this box was opened and retaped. It's going to really look open and retaped when I get done. Oh, I'm not going to retape it. I'm probably just going to keep this. So I think I can use this water hose on my torch, so it'll be a spare hose. Yeah, that looks brand new. So what we've got is, you can see it's got the right-hand thread, or the reversed left-hand thread. The reverse thread. Got the little cut marks in there. On the other end, it's got nothing, because on most of these torches, this slides over a part that's actually part of the torch and then gets clamped on. So since it's a 25-footer, I should be able to keep this as a spare replacement hose for my torch. All right, now the moment of truth, what we were all waiting to see. So for those of you who haven't been following along, the way I came up with this number, the 45V04, is I went to the ESAB website, which is the manufacturer of my water-cooled torch. I looked at a parts breakdown for my model torch, and it gave that part number, the 45V04 part number, as the part replacement. Then I Googled that, or I threw that in the search engine on eBay, and lo and behold, I found this Thermocut Advanced Consumables made in the USA. Well, that looks pretty good. That looks really good. That sure looks like the big nut that goes into my power block. And that looks like, I believe it's the 1/4 inch fitting that screws on to my torch head. So we're looking good there. So what I can't wait to do is blow through this and see whether or not this seems any different than my cable from hell. It seems pretty good. It's been a while since I've been down here though. I think I really need to blow into the other one. Alright, so it's been a while since I tried this thing. I'd completely forgotten that it's actually feels like it's almost completely blocked. I just took about 10 minutes to undo a whole bunch of electrical tape. What somebody had done was they had bound the 3 hoses, the 3 lines together with electrical tape at about 3 or 2 foot intervals to keep it as an assembly. I've got that nylon sock coming in to do that job, but that's coming on the slow boat, so that hasn't come in yet. But right now it's almost completely blocked. I can blow as hard as I want into this. I can't get anything to come out of this. This, of course, is my makeshift repair inside here. So the first thing I'm going to do is I'm going to cut this off again and see if that doesn't free things up, because it might be just the way that this is put together now. Oh yeah, all I did was move that a little bit and start to work. Well, now that's weird. It's almost acting like a check valve. I can blow into this end. And if I blow as hard as I want into this end, nothing comes out here. So something's going on inside here. What the heck? Alright. It's pretty blocked that way. Yeah, this has got issues. This actually doesn't seem too bad. Just curious in comparison to this one. How is it? This does seem a little less restricted than this, but not much. So I think it's still an issue with my repair on this that's causing the problem. That's a shame. Part of me actually wanted this to be hard to blow through, and that would make me feel that, oh yeah, it definitely was more problems with this cable, and it wasn't just this fitting. So probably what was happening was when I was pushing this back in to the hose, it was causing this to crumple up on itself. Oh, I know what happened. It's because I couldn't get the full cable to fit into here, so I cut back the strands, and then the cut off ends of the strands, when I pushed this back in, it pushed up and out of position and caused my problem. So I bet you now that I've removed all the other cable out of the way, but you now this is, yeah, it's free. All right, so I think I could repair this cable if I could get the proper connector connected on here in the proper way. But I haven't had any luck finding a reasonably priced one of these, considering how cheaply I bought this whole hose. It's just not worth it. So I think we're just going to give up on this altogether. Throw this in with the scrap brass, although this has got copper. This is mixed. That nut, I don't think I'm going to need it. That'll go in scrap brass. A couple of other items that came in for the project. I bought a bottle of CLR, calcium, lime, and rust remover, because I read online that this actually can be run through the head of the TIG torch and help with any corrosion or calcium or lime buildup inside those really small orifices in the torch. And I'm pretty sure that the guys who were last running this thing were not using dedicated torch fluid, that they were using regular tap water or at best deionized water. So I think it wouldn't hurt to run some of this through. And next I decided to break down and spend the crazy money, in my opinion. This is probably a complete rip-off. I think shipped this was $40 for 1 gallon of Weldmark Weld Cool WEM WM 929. Now, the reason why I chose this of all of the different products out there was because I found it listed on eBay. And, well, let me start by saying this. My Dynaflux water cooler, which is very expensive new, the manufacturer specifies a product called Defense 929, okay? And I'm not sure what the 929 actually signifies. I don't know if it's supposed to be a certain formula or what. But Defense 929 is a antifreeze pump lubricant formulated for their types of coolers. So I figured, oh, well, that'd be good stuff, right? So then I go on eBay and I find, bear with me 1 second here. Let me show you what I found. So this is what I find. I find Weldmark Defense 929 TIG coolant for water recirculators / coolers. $19.95 a gallon plus $17.70 shipping. So it was less than $40. Okay. So that's like $37.65, right? $37.65 gets me a gallon of this blue stuff here that they're calling Weldmark Defense 929. And when I went online and kind of Googled that and messed around, it appears to me that's the same product as the Defense 929 that's sold for the Dynaflux coolers. So far, so good. So I buy this. I buy this right here. This is the auction I bid on. This is the item. Well, this is the buy it now. This is the item that I bought. This is what I get sent. Okay? So I got a little problem with that. If this stuff was blue, I probably wouldn't care, because if it was blue, I would feel a lot more confident that I actually got what I paid for. All right? But if you notice, this does not say Defense anywhere on it. This is Weldmark, same manufacturer. This is WeldCool WEM WM929. So this WM929, and WM is Weldmark, obviously. The 929 is there, okay, but this doesn't say Defense. It does say that it's antifreeze. It does say it's a pump lubricant, and it does say it's a coolant. So I think it's going to be okay, and I think it's going to work okay. And so I'm not going to go through the trouble of returning it, but I am annoyed because it's not the pretty blue color. No. You guys get where I'm coming from, right? You know, if you're going to substitute, okay, if you're going to substitute a product, you should tell the people ahead of time. This is that old cable, but I have an idea on how I can use this old cable to help me flush the head with the CLR. Note the blue corrosion color. Now I'm just going to modify what's left of this on the grinder. Well, everybody, it's Sunday morning, January 14th, and I made up my little cheat fitting here. I just cut off the section of this fitting that the wire would solder to, and then made sure the hole was open. So now I get really good flow through this little fitting. And what I'm going to do, oh, my voice just cracked. Do, and if you do, does anybody know what movie that's from? Anyways, I'm going to take a scrap of this hose that I've got left over. I'm going to force this back onto this fitting. And I'm going to use this so that I can pump a mixture of water and this wonderful CLR through my torch head. Alright, so this is going to be my setup. Ideally, what I would have liked to have done is I would have liked to have removed the other hose, the other coolant hose, off of the torch head, and then used a very small little pump that I have to literally just right at the bench with a little cup force pure CLR undiluted through the torch head for a couple of minutes. But to do that, I'd have to remove this hose. The hose is safety wire tied to the actual torch head, and I really don't have any of this safety wire material. So when I was messing around with the other thing, I just used a piece of scrap wire, and I noticed when I was twisting it, it didn't really have the tensile strength that it should have. So I really don't want to mess with taking this connection off. So I'm stuck with about 24 feet of this hose, which has a small amount of volume, but it's enough to mean that I've got to use more liquid than I had planned on to do this flushing. So I'm going to use the Dynaflux pump, and I'm going to have to dilute the CLR with water. But I want to use the minimum amount of water to CLR ratio for better cleaning. So what I've got right now is I've got just deionized water in the tank here. I've got the hose. It's actually the supply hose hooked to the torch head, And then I've got my little cheat fitting that I just made with a little scrapper hose coming into this jug. So what I'm going to do, and I got the torch just kind of hooked in there so it won't fall out, hopefully. And what I'm going to do is I'm going to run this until it stops pumping, and then as soon as it stops pumping, I'll shut it off, and then I'll see what the level is here in the tank, and then I'll know that that's the minimum amount I can have in the system, and it'll still pump. And then I'll add CLR to that, and that should be enough to just get it to pump again, in theory. Alright, so that happy little noise there means that we've reached pretty much the minimum amount I think that's going to tolerate. Just double check. Well, that level can go pretty low, which that's actually good news because I only bought a gallon of that coolant. I almost bought 2 gallons thinking a gallon wouldn't be enough, but I'm glad I didn't because the stuff, like I said, it's like with the shipping it ends up being about $40 a gallon. So CLR can be used in any number of concentrations, and on the back here it kind of gives you an idea. Like it says for really stubborn situations you can use it straight, but that's like if you're wiping it onto a surface and cleaning like stained brick or tile or something like that. It goes on to say that for like shower heads, toilets, tubs, sinks, all kinds of things there. It's basically they recommend a 50-50 mixture of water to CLR. Then down further, coffee makers, 1 part to 8 parts. Okay, so that's interesting. They're basically, you're looking at like a 12.5% solution. 12.5% of CLR to, let me do the math. Anyways, and then for washing machines, it says add a half a cup to an empty load. So you think about your typical washing machine, how many gallons that's going to use. They're basically saying that's going to be a half a cup to however many gallons a washing machine is going to use. So that seems pretty diluted. So I guess even in a mild dilution like that, this stuff will work. So I don't think we need to put too much into here. So let me think about this. All right, that's a 28-ounce container of CLR. I added about half of it, so I estimate that I probably put in about 12 to 14 ounces of CLR. But I don't know what the volume of that tank is, or how much was left in there. I did make a pencil mark on the tank. There's my pencil mark I made on the tank, and there's my new level. So it's about 1/4 of an inch higher than it was. If that doesn't work, then I'll just add, I got my funnel in there. I've got my little makeshift return line going right back into the top of the tank, and I'll just add a little bit more deionized water to the thing until it's pumping good, pumping well. That stuff foams up. Looked like it was foamed up, but it doesn't look like it's foaming too bad when it comes out. And it's coming out in a steady stream, so it's doing a good job. So I'm just going to let that run for a couple minutes. Alright, that's been running about 3 minutes now. What I'm going to do is I'm going to take these 2 little scraps of aluminum and these vice grips, and I'm going to clamp down on the hose at the output. And what that's going to do is that's going to force the bypass valve, the spring-loaded bypass valve, to open. And because as long as I'm doing this, I might as well clean out the whole system. And that little section of hose and and the bypass valve itself, and that whole assembly, if there's any buildup inside there, I want to get fluid flowing through there. There we go. I don't have any flow coming out of the hose right now, so I know it's going to bypass. So I'll just do that for a couple of minutes. clean water through there to rinse the whole system. So for starters, I'll take this tube and route it into this bucket and pump as much out as I can pump out of the solution, and then I'll add water and keep doing that until I'm satisfied that it's pretty purged. So it's got a white milky look to it, so it should be pretty easy to tell when I've got it cleaned. Alright, as this bucket fills up, I'll dump the bucket, rinse the bucket out, and then keep adding more clean water to the system, and that'll take a little while. So after having to dump that bucket several times, I realized, well, just be smarter to bring the whole thing over here to the slop sink and hook a hose up. So I've got water continuously running at a slow rate into the tank, and it's being pumped out through the TIG torch down the drain. Okay, I've reconnected up the cooler, and I'm gonna put the coolant in there and get ready to test and see how good the flow is with the new hose. I taped up the lines a little bit with electrical tape just to kind of keep them together, but I didn't do much because I'm gonna wait when that nylon sock comes in, the protective sock comes in, and I put that over the lines. That should help keep them bunched together. The other thing I did was I decided to take the advice of a couple different people, because it makes perfect sense to me to completely omit running the water through the solenoid. So the coolant solenoid, I'm not using it. So this line right here, this is the output of the cooler. I've got this going directly to the torch head, and then the coolant comes back, it goes to the power block down below, and then comes from the power block up to here and dumps back into the reservoir, which means as long as the coolant is being powered, doesn't matter whether or not the contact is open or closed, coolant will be flowing through the torch head. People pointed out that they believe that the purpose of the solenoid was only for situations where you were hooking this up to a faucet and running tap water through here. So I electrically disconnected the solenoid, and then I decided, you know, I think since I don't even want those wires hanging around in there, I just completely removed the solenoid altogether. So I took it out completely. I was going to get a double female coupling and thread this and this into a double female coupling so that I could still use one of these hoses, but I really don't see the point in that. So I just ran the torch hose directly to there. So I'm going to add some coolant, we're going to fire it up, and we're going to see, hopefully, a lot better flow coming back into this tank. Alright, I'm get ready to fire it up. I'm going to actually hold the hoses here. I want to see if I can actually feel the temperature drop. Yeah, believe it or not, I can actually feel this get cooler. There's absolutely no color to that coolant they sent me. Unlike the picture that showed it being tinted blue, it's absolutely colorless and odorless. It could be deionized water, and I don't think I'd be able to tell. The only thing I could do is I could test it by putting some in the freezer to see if it freezes. You know, if it freezes, then it would mean that they're basically sticking water in gallon jugs and selling it. But I highly doubt that, because even though I bought it off of eBay, it came from a welding supply company out in the Midwest. So, well, that's no guarantee that they wouldn't do something like that. But it's, you know, why risk that? Yeah, that flow is definitely better. Instead of the water just like dripping back, you know, out that way, it's actually squirting out to about halfway across the tank. So I think I'm gonna top off that fluid level just a little bit more so it stops sucking that little bit of air. Okay, I'm satisfied with the flow. Alright, so next up, I'm going to test, rejuvenate, and install that solid state post-flow relay module in place of my old electromechanical one. Take care.